What will the universe look like 10 trillion years from now? The answer might be beyond anything you can imagine. In about 3.7 billion years, the Milky Way will collide with the Andromeda Galaxy. After a long period of gravitational balancing, the two galaxies will merge into one massive new galaxy. 5 billion years later, the hydrogen inside the Sun will be completely used up. Its outer layers will start to expand under intense outward pressure. It will become a red supergiant. By that time, the Earth and the Moon will be swallowed by the Sun. They'll slowly lose their orbits due to friction, and eventually fall into the endless sea of fire inside the red giant. 10 billion years later, the red giant Sun will fade away into a planetary nebula. At its center, a white dwarf will remain. Next, the second law of thermodynamics will take over. Over an unimaginably long period of time, we'll find that the amount of hydrogen available to form new stars keeps decreasing. While heavy elements become more and more common, the final result is that the universe will no longer have enough material to create new stars, and so, within just a few 100 billion to several trillion years, every star in the universe will go dark. Neutron stars and white dwarfs will also cool down, no longer able to shine or produce heat. Even black holes themselves will slowly lose mass due to Hawking radiation, and eventually evaporate completely. That will smooth out the once warped fabric of spacetime. In a universe where even black holes are gone, what's left will be nothing but darkness and cold. Close to absolute zero, all matter in the universe will only move at the microscopic level, just tiny quantum fluctuations. If anyone were still alive by then they would see a completely pitch-black universe. There would be no light source in any direction. Even time itself would lose any large-scale meaning. This is what we call the heat death of the universe. However, some scientists believe that before the heat death arrives, the universe will meet another kind of ending. That is, everything will be torn apart by the power of cosmic expansion. Right now, the universe expands at 72 kilometers per second. For every 3.26 million light years, at this rate, once galaxies are more than 14.5 billion light years away from Earth, they'll be moving faster than the speed of light, meaning we'll never see or reach them again. Out of the 2 trillion galaxies in the observable universe, about 98% have already passed that distance. In the future, as dark energy keeps pushing expansion, the expansion of the universe will only get faster. If dark energy continues to make up about 70% of the universe, then in just 22 billion years, its expansion force will be strong enough to act on every single atom. Before that happens, the cosmic walls, voids, superclusters, the Milky Way, and even the solar system will already have been torn apart by expansion in the final moment. The Earth and every atom that makes it up will also be ripped apart by then. The entire universe will return to a state of basic particles. Maybe it won't stop until it reaches the Planck scale. But thankfully, dark energy hasn't actually been discovered yet. It's still just a theory to explain the accelerated expansion of the universe. In the future, our understanding of the universe's evolution may lead to completely new theories. But one thing is for sure. If the universe had a beginning, then it will definitely have an end. But for us, we've only lived through a single fleeting instant of the universe. It's impossible to truly see the full picture in such a short time. That's why, to us, the universe will always remain mysterious and unclear.